Every time two AI agents need to talk to each other, most frameworks send that conversation through a paid LLM API. You pay for tokens just so one bot can tell another bot what to do. A developer just posted a way to cut that cost to zero, and it runs entirely on your local machine. This is not a new framework. It is not a new model. It is a communication layer. And once you see how simple it is, you will wonder why every multi-agent setup does not already do this. So what does it actually do? The core idea is that agents do not need an LLM to understand each other. They need a protocol. Think of it like HTTP, a dumb, reliable format that two programs can use to pass structured messages without either of them needing a brain in the middle. In this setup, each agent exposes a lightweight local endpoint. When the planner agent decides the executor agent needs to run a task, it sends a plain structured message, a small JSON payload, directly to that endpoint. No API call. No token cost. No round trip to OpenAI or Anthropic. The receiving agent parses the message, acts on it, and sends back a result in the same format. The demo on the project page shows two agents coordinating a multi-step task. One breaks down a goal, the other executes subtasks, and they exchange status updates between steps. The entire coordination loop runs locally. The only time an LLM gets called is when an agent actually needs to reason, not when it needs to say task complete or step 2 ready. That distinction matters more than it sounds. In most agentic frameworks, every message between agents goes through a model. That means you pay tokens for bookkeeping. You pay tokens for routing. You pay tokens for status updates that are just structured data pretending to be language. This protocol strips all of that out. LLM calls happen at the edges, when an agent needs to generate a plan or interpret ambiguous input. Everything in between is just a lightweight local message. Now here is what it does not do, and this is where honest context matters. This is not a full agent framework. It does not handle memory, tool use, retries, or complex state management. If you are building something that needs agents to browse the web, write code, and self-correct over dozens of steps, this alone will not get you there. You would still need to wire up those capabilities yourself. It also does not handle the cases where agent communication itself requires reasoning. Sometimes the message between agents is not structured data, it is ambiguous, context-dependent, and genuinely needs an LLM to interpret. This protocol assumes you have already solved that problem upstream. If you have not, you will still be paying for tokens. And there is no built-in security model. If you are running agents that talk to each other over a local network in a production environment, you need to think carefully about who can send messages to those endpoints. The project does not address that yet. What surprised me was how much of the complexity in existing multi-agent systems exists not because it is necessary, but because the tools were designed around LLMs as the universal interface. When you step back and ask which parts of agent coordination actually require language understanding, the answer is a much smaller subset than most frameworks assume. That insight is where the future potential lies. Right now, this is a proof of concept, 2 or 3 agents talking on a single machine. But the same pattern scales. You could run each agent as a separate service on a small cloud instance. The coordination overhead stays near zero. The only costs are inference costs for real reasoning tasks. If you were building a pipeline where 10 specialized agents each handle one step, one agent reads documents, one extracts entities, one validates, one formats output, the coordination between them does not need to cost anything. With this approach, it does not. You could also combine this with a local model like Allama or LM Studio for the reasoning steps, and suddenly your entire multi-agent system runs at near zero marginal cost per task. That is a real deployment architecture, not a toy. If you are deploying something like this and want it to scale beyond your laptop, DigitalOcean droplets are a clean way to run each agent as a separate lightweight service. You pay for compute, not for tokens, which is exactly the cost model this project is designed to enable. So why does this project exist? Because most multi-agent tutorials start with the assumption that you have a healthy API budget. The implicit model is, intelligence is expensive, coordination is cheap, and you spend on the former. But in practice, coordination costs add up fast. logging, routing, chaining, status checks, all of it runs through the same paid endpoint as your actual reasoning. This project exists because one developer got annoyed paying for tokens that had nothing to do with intelligence. The solution is almost embarrassingly simple: define a local protocol, route coordination messages through it, and reserve LLM calls for work that actually requires them. Is it a complete solution? No. Is it a clean answer to a real and growing cost problem in multi-agent systems? Yes. If you are building with agents and you have not separated your coordination logic from your reasoning logic, this is worth an afternoon of your time. The concept will change how you think about where intelligence actually needs to sit in your pipeline. Next episode, we are looking at a tool that does the opposite. It uses a small local model to replace an expensive GPT-4 call in a production system, and the accuracy gap is much smaller than you would expect. Subscribe so you catch that one.